Bismillah ar-Rahman ar-Rahim. This is me, Abrar Muhammad SAYAF. Hope you will be enjoying the lockdown. So stay home, you stay safe. Most of my students insist me to make videos lecture, so I decided to start short videos in which I will explain different concepts. So today our topic is how to predict the hybridization. This is a very important concept, and today I will try my best to give you some points and tricks so that you can easily predict the hybridization of a central atom in a molecule. So first, what is hybridization? Hybridization is basically the mixing of one or more atomic orbital to form new hybridized orbital. The atomic orbital may be of different shape and different energy, so they are called unhybridized orbital. When they mix and the new hybridized orbital is formed, they will have the same shape and same energy. Keep in mind, the number of hybridized orbital formed is equal to the number of atomic orbital. It means if two atomic orbital mix up, so two hybridized orbital will be formed. If three mix up, so three hybridized orbital will be formed. Types of hybridization. It depends on the number and types of atomic orbital combined. So let us discuss some few important types of the hybridization. It is sp, sp2, sp3, sp3d, sp3d2, sp3d3. Keep in mind, sp, sp2 and sp3 are common in organic compound, and sp3d, sp3d2, sp3d3 are common in coordinated compound. Now next, how to predict the hybridization of a central atom, a very important one. We can find out the hybridization of a central atom from the steric number. Now what is steric number basically? This is a number which designates the type of hybridization. So when the steric number is 2, the hybridization is sp. When it is 3, then the hybridization is sp2. When it is 4, the hybridization is sp3. 5, so the hybridization will be sp3d. And when 6, the hybridization will be sp3d2. And when the steric number is 7, the hybridization will be sp3d3. Why this is 2? 1s and 1p, so 1 plus 1 is equal to 2. Why this is 7? 1s, 3p and 3d, so sum of all these give 7. Now how can we find the steric number? We can use many formulas. The first formula is steric number is equal to atoms attached to the central atom and lone pair with the central atom. Okay, how can we find out the lone pairs? So I have a point that is the group number 1, 2, 3, 4 have no lone pair. The group number 5 have one lone pair. The group number 6 is 2 lone pair, and group number 7 have 3 lone pair. You have to remember this. The second formula for finding the hybridization is Z is equal to half into valence electron plus negative charge minus positive charge plus monovalent atom attached to central atom. This formula is very important, and it is applied to each and every molecule or ion. I will suggest you this formula. Okay. So what does mean by the monovalent atom attached to a central atom? Any atom which is bonded singly to the central atom are called monovalent atom. We will discuss it in later. The last formula, which is best for the organic compound, is sp to the power n minus 1. Now what is this n? The n is the number of atoms attached to central atoms. Now let's discuss some few examples. We will discuss the hybridization of beryllium in beryllium dichloride. We will use these two formula so that I can show you that how can we find out the hybridization of beryllium in beryllium dichloride. If we look at the beryllium dichloride, the beryllium is the central atom which is attached to the two fluorine. So according to this formula, the numbers of atom attached are 2 and beryllium belongs to the second group, has no lone pair, so 2 plus 0 is equal to 2. Okay, now the steric number of beryllium in this case is 2. Now according to this formula, you can see this is half valence electron. Beryllium belongs to the second group, has 2 valence electron. There is no charge on this molecule, so I will write the negative and positive charge as 0 plus. Now the chlorine is the monovalent atom. It is attached to beryllium through single bond, so monovalent attached are also 2. So 2 and 2 is equal to 4. So this will be like this. So 2 1s are 2, 2 2s are 4, 1 2s are 2. So the steric number according to this formula is also 2. So when the steric number is 2, the hybridization is sp. So beryllium in this case is sp. Now let us discuss another example, is BF3. Looking to the BF3, boron is the central atom and fluorine are the number of atoms attached. So according to this formula, the number of atoms attached are 3 and boron belongs to the third group, has no lone pair, so 3 plus 0 is equal to 3. So the steric number is 3 according to this formula. Now according to this formula, we will write how boron belongs to the third group, 3 valence electron. There is no negative charge, there is no positive charge. Fluorine is the monovalent atom, so there are 3 monovalent atoms. So we will get this 6 by 2, so 6 divided by 2 is equal to 3. So according to this formula, this is also 3. So when the steric number is 3, the hybridization is sp2. So boron has sp2 hybridization in this case. Now let us discuss the last example, IF7. If we look into the IF7, the iodine is the central atom and it is attached to 7 fluorine and there is no lone pair with iodine in this case. So I will write 0. So 7 plus 0 is equal to 7. Okay. Now according to this formula, half. So valency or valence electron of iodine are 7. Belong to the 7th group. There is no negative charge here, and there is no positive charge. And the monovalent atom are 7. Okay. So 7 and 7 is equal to 14 divided by 2 is equal to 7. So when the steric number is 7, the hybridization is sp3d3. So the hybridization of iodine in this case is sp3d3. Now let us discuss an ion. Consider NH3, NH4 positive. If someone asks me what is the hybridization of nitrogen in this case, so according to this formula, the number of atoms attached are 4 and nitrogen has no lone pair in this case, so I will write it 0. So 4 plus 0 is equal to 4. So, okay. Now according to this formula, I will write half valence electron. Nitrogen belongs to the 5 group, so I will write the 5. There is no negative charge, so I will write 0. There is plus 1, so I will write the 1. Not plus 1, just I will write the 1. Minus 1 plus. There are 4 monovalent atoms. Okay, hydrogen is monovalent. Now if we calculate this, 5 minus 1, 4, and this will be 8 divided by 2. So 8 divided by 2 is equal to 4. So when the steric number is 4, the hybridization will be sp3. Okay, so in this case, the hybridization of nitrogen is sp3. let us discuss the hybridization of radical or positive and negative ions. We will discuss the three examples to understand the hybridization of radical and okay. First, we will discuss the CH3 positive ion. How many atoms are attached to the carbon? 3. If there is any lone pair, no. So, the steric number. If we use this formula, how many valence electrons are there with the carbon? 4. So, there is no negative charge, but there is one positive charge, and monovalent atoms are 3. There are 3 hydrogen attached by single bond. So 4 minus 1 is equal to 3 into 3, 6. So the steric number is 6. When the steric number is 3, the hybridization will be the sp2. So in this case, the hybridization is negative. Now, the next example, that is CH3 negative. If we look at this ion, there are 3 atoms attached, and the carbon has one lone pair. How the carbon has one lone pair? There are 3 hydrogen attached, while the one of its electron has not involved in the bonding, and second, it has gained another electron. That is why there has a negative charge. So these 2 electrons are acting as a lone pair. So 3 plus 1 is equal to 4. Now using this formula, half valence electron are 4. There is one negative charge. There is no positive charge, and monovalent atom are 3. So this is 8 divided by 2 is equal to 4. So when the steric number is 4, when the steric number is 4, the hybridization is sp3. So in this case, the carbon is sp3 hybridized. Now let us consider the last example. That is a benzene with a radical. Okay, if you look at this carbon, attached atoms are basically 1, 2, and here is also a hydrogen 3. How many lone pair are there? This carbon is has no lone pair, so steric number is 3. If we use this formula, this is half valence electron are 4. There is no negative charge, no positive charge. And how many monovalent atoms are there attached to it? If we look at these, monovalent means atoms attached by single bond. So there are 2 single bonded atoms which are bonded by single bond. So I will write here only 2. So 4 plus 2, 6 divided by 2. Okay. So the steric number will be. So when the steric number is 3, the hybridization is sp3. Okay, now let us use another formula, which is Sgn minus 1. The n is the number of atoms attached to the central atom, which is mostly carbon in organic compound, and you can use this formula mostly for the organic. Let us find out what is the hybridization of carbon number 1. So we have the formula Sgn minus 1. Now what is n? N is number of atoms attached to this carbon. So there are 4 atoms attached. 3 are hydrogen and 1 is this carbon. So it is 4 minus 1. So 4 minus 1 is equal to 3. So the carbon number 1 is sp3 hybridized. Now let's check the second. Carbon number 2. We have the formula Sgn minus 1. So this is Sp. Now here the n is 3. Why? Because this carbon is attached by one bond to this carbon and by double bond to this carbon and one hydrogen. So the n is 3. So 3 minus 1 is equal to this. So the hybridization of the carbon number 2 is sp2. So the same case is in the third carbon. Now let us find out the hybridization of the carbon number 4. What is the hybridization of the carbon number 4? Okay, if we look into the carbon number 4, it is attached by single bond to this carbon and by triple bond to this carbon. So the number of attached atoms are 2. So 2 minus 1 is equal to 1. So the hybridization of the carbon number 4 is sp. And carbon number 5 is also sp. We have to check. Now let us check what is the hybridization of the oxygen. Okay, this. For this we will use the another formula. Which one? That is attached atom plus lone pair, as already discussed earlier. So how many atoms are attached with the oxygen? 2. One is hydrogen and one is this carbon. And how many lone pair are with oxygen? As you know, oxygen belongs to group number 6, so it has 2 lone pairs. So I will write here 2. So 2 plus 2 is equal to 4, and when the steric number is 4, the hybridization is sp3. So oxygen is sp. Okay. To give you a shortcut for the carbon hybridization, a carbon with single bond is always sp3 hybridized. A carbon with double bond is always sp3 hybridized. And a carbon with triple bond is always sp hybridized. You must have to keep these. I hope you have understand and enjoyed the video lecture. For new lectures, follow and subscribe me on Facebook, Instagram, and YouTube. Bye. Take care.